Okay, we have 30 minutes left and we're on to our final piece of content, which is our classifying and representing data, which is from S1.1, our first part of our statistics unit. So you'll see it's quite long. I'm going to give you a second to read while I catch my voice for a second. It is a long time to talk without stopping. Okay, so what are we doing? We're describing and using appropriate data collection methods for populational samples. We're classifying data relating to a single random variable. We are reviewing how to organize and display data into appropriate tabular and or graphical representations. And we're interpreting and comparing data by considering it in tabular and or graphical representations. Okay, how do we do all of this? Let's find out. There are heaps of different ways that we categorize data. So this is in our classifying data section. We're going to take a look at this diagram. So we start off with having a piece of data. Let's say we've interviewed a bunch of people about their preferred color of a car. We then have either categorical or numerical data. Categorical is about categories. So what's your favorite color of car is categorical. If it was how many kilometers would you prefer on the car you buy, it's numerical. So we have two distinct categories. Categories, you know what I mean? Categorical, these are things we can put into different categories. Numerical are number-based, so on and so forth. Then we go further down. So we end up with four different things, four different categories. So nominal categorical is when there is just different categories. So red car, blue car, green car, white car. Ordinal would be if there were categories that go in order. So say it's your grade, A, B, C, D, E. There's an order to those. Numerical discrete is a number that is a whole, so you can't be, there can't be 2.5 people. There's 2 people or there's 3 people. Continuous would be like your height. You could be 153.54721 centimeters, right? You can kind of go as far past the decimal point as you want. So characteristic divided into categories, numbers able to count, order of categories, categories have an intrinsic order. So rankings versus something like eye color, car color, hair color. Discrete number, like a discrete, it has to be an exact number. So it's number of people, number of days in a week. You can't have 7.6 days in a week, there's 7 days in a week. Continuous, any numerical value within a range. So mass, you could be 61.547 kilograms. Okay, here are some ways that we collect data. So number 1, census. This is about collecting data about every individual in the whole population. So we have an Australian census that runs every 4 years from memory. And this is something that they might mention in questions sometimes. Sample is about collecting data about a portion of the population. So you might just want to collect a sample from year 12 students. A bias sample is data that has been unfairly influenced by the collection process. So it's not truly representative of the population. This might be if you wanted to interview people about how they felt about reality TV, but you only interviewed people who actually like reality TV. Kind of a biased sample. A self-selected sample is a voluntary response. So you choose to be a part of it. It might be fill out this survey about your local parks and it's just posted online and anyone can fill it out. Random sampling is when every member of a population has the equal chance of being selected. So it might be we're going to choose 5 people from this group of 50 people in this maths class. Everyone has an equal chance of being one of those 5 people. All right, stratified random sampling is sample made up of random samples taken from subgroups. So you might take 7 students from year 7, 6 students from year 8, 9 students from year 9, so on and so on. Stratified random sampling. Systematic sampling is when everyone gets put in order and then every certain number of person is chosen. So let's say you have a roll of people that are alphabetical and every 5th student is chosen to be part of the sample. So what is the correct classification of this data? The brands of toothpaste used by members of the population. So we have our data. Is it categorical or is it numerical? Brands of toothpaste is a categorical piece of data. Now, is it ordinal or is it nominal? Is there an intrinsic order is there an order like there are ranks, or is it just different categories? It is just different categories. So categorical, ordinal. Didn't leave the answer up, but categorical, ordinal. So moving on from that, we're going to talk about frequency distribution tables. This is a tool we use to help us display data. This is what it looks like. We have the number of pets that people own, a tally of when we would take that survey, and the frequency. This is how often somebody owns 0 pets, how often somebody owns 1 pet, blah, 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 on and on. Okay, couple points. Number 1, the classes, which are what we call this first column, the piece of information, cannot overlap. So you couldn't do 0 to 1 pets, 1 to 2 pets, 2 to 3 pets. Because if someone has 2 pets, which one do they go in? This one or this one, right? The classes cannot overlap. It would have to be, let's take this example, 10 to 19, 20 to 29. You cannot have overlapping classes. Even if a number has no data, like let's say 5 pets, there was no one, you still have to include it if it's in the data set. Each interval must also be the same size. So you can't do 0 to 1 pets, 2 to 6, 7 to 8. Everything has to be the same size. We see that in the example sitting there. So cumulative and relative frequency, what's this? Cumulative frequency is the sum of all of the frequencies of the scores. So going back here, the scores were our tally. So 4 people have no pets. 6 people have 1. 5 people have 2. 3 people have 3. 2 people have 4. Cumulative frequency is adding all of those together. So cumulative frequency for score 3 would be all of score 1, all of score 2, and all of score 3 added together to get up to 11, the cumulative frequency before the score you're talking about. Relative frequency is the number of times that a score occurs as a fraction of the total number of scores. So let's take an example, the relative frequency of 5. Well, 5 only occurs once, and there are 14 total scores. So 1 over 14 is a relative frequency of 5. We could also convert that to a percentage. So 1 over 14 is going to be 0.07, which is a 7% chance that you have a score of 5. Percentage relative frequency is that relative frequency as a percentage. So we do our relative frequency in a fraction and our percentage relative frequency as 7%. Dot plots. These are super, super simple. They are a physical, graphical, visual representation of where scores are represented. So this question was, how many minutes does it take you to eat breakfast? So 1, 2, 3, 4, 5, 6 people take no minutes, probably because they don't eat breakfast. 2 people take 1 minute, 3 people take 2 minutes, 5 people take 3 minutes, so on and so forth. This is what it would look like if you ask a question, how many people take 5 minutes? You would go 1, 2, 3, 4, 5. There are 5 people. If the question was how many people take more than 6 minutes, you would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 people take 6 minutes or more to eat breakfast. Okay, stem and leaf plots. I'm just giving you an overview of all of our different methods of displaying our data. You are literally imagining a stem and leaves like this. Nice little graph for you there, or drawing for you there. So this is our stem. Let's say our stem, we have, we can say our plant goes out there. We have 4 different stems. 1, 2, this is number 1, this is number 2, this is number 3, this is number 4. Each leaf is a little number. This is the leaf 1 and 1. Then we have 2 leaves that are called 2. 1 leaf called 3. 4 leaves called 4, so on and so forth. So all it's showing you is that this piece of data here is 10, 10, 10, 11, 11, 13, 17, 19. This is 63, 66, 52, 56, 57, 57, 58. So you're just adding these 2 numbers together to create a full number. So instead of having to write 52, 56, 57, 57, 58, you just write the 5 once. Hopefully that makes sense. So this is our stem. Every number on the left is attached to those on the right. Okay, we're going to do a quick refresher on column, line, and bar graphs. So how do we construct these? What are our rules? You always have to double check your horizontal and vertical axis. So is the correct data in the right spot and are they labeled? Second thing, make sure your scale starts at 0. If it doesn't start at 0, you have to do this little jump thing where you add kind of a squiggly line in there, and then you can start at 10. Down here, sorry. You'd start at 10 here and this would be 20. You have to do a little squiggly line to show that that's happening. You should be able to see it on examples, but most of the time you should be starting at 0. Make sure the scale is regular. See how they all increase by the same amount of time? This one's always by a month, this one's always by 1, and this is always by 5. And it always has to go by the same amount on the same axis. So you can't switch it to like 5, 10, 25, 5, 10, 50. You've got to go by the same amount the entire time. These two don't have to match because they're going to be different variables. You also have to make sure the line is exactly following each point. So you can't draw 4 hamsters to here, right? Where it's like 4.7. You also can't draw January to February over here and then March is back here. You have to line them up with each piece of information. Also, when you have column or bar graphs, you need to leave a space between each bar, which has been done on each of these. Okay, a histogram. What is a histogram? Now, this is where spaces aren't necessary because we're looking at frequency histograms and polygons. A histogram is a graph, column, or bar, a column graph or a bar graph, in which the values of the variable are placed on the horizontal axis and the frequency of the variable is on the vertical axis. So these are the values. So let's say the question was, how old is each person? 34 to 40, 41 to 47, so on. This is how many people are in that age range. What it's doing is there is one person who is 34 to 40. No one is 41 to 47. 5 people are 48 to 54. We've drawn bars for each of those. Now we've done the number of people. Frequency polygon is how we then create a line graph out of that. So we join the midpoints of the top of the column of each column in the frequency histogram. So we start at the bottom left of the first column. We draw a line to the top middle. We then just draw lines to the top of each bar or column in our graph. And we end by going to the bottom right corner of our last bar or column. That is a frequency polygon. So the polygon is representing a line. Okay, this is a bit more complicated. See how we have, first of all, I want to point out our little jump here. So we jump to 20 and then we go 22, 24, 24, 24, 26, 28, so on and so forth. Cumulative frequency histogram is a histogram with cumulative frequency on the vertical axis. So this is saying, say our scores were one person had 22 centimeters, 3 people had 24 centimeters, 4 people had 26 centimeters. Our cumulative frequency by the time we get to 26 is going to be 8. So at 26, say we'd be at 8 if that was correct. So it's always going up. It's just the cumulative frequency of all of the scores added together. A cumulative frequency polygon would be if we had drawn columns on here and then we drew a line that followed all the upper right-hand corners. So if we just went like this the whole time through the upper right-hand corners, joining each column of the cumulative frequency histogram. Okay, Pareto charts. Pareto charts follow the 80-20 rule. This is a rule I was talking about earlier. Generally speaking, 80% of your marks in your HSC exam are going to come from 20% of the work you did. It's just a basis of the Pareto rule. Pareto charts follow this rule and say that 80% of something occurring is the fault of 20% of something else. So let's have a look. Defects in shirts. 80% of the defects are being caused by the culmination of button defect. So when we look at the number of defects and we follow this line, we want to say that the culmination of button, pocket, and half of the collar defects is 80% of the defects. So this is only feeding into that lower range. It's just about where our line goes. All right, we're going to look at a practice question now. Fill in the blanks below. Data that can be divided into categories would be categorical. Data that reflects numerical values will be nominal. If there's no order, it's categorical ordinal. If there is an order, it's categorical nominal. I know that it's kind of complicated, but stick with it. If there are exact values, it's numerical discrete. If it's no exact values, it's numerical continuous. Sorry, nominal is no order, ordinal is order. I went the wrong way around there. Okay, have a look at another practice question. A company has the following demographics. 20 to 29, there's 134 employees. For people aged 30 to 39, there's 57. 40 to 49, there's 114. 50 to 59, there's 76. The company needs to survey 25% of the company. How many employees are taken from each subgroup? So we need to find what 25% of each of these are to find the total 25%. So we need to do 134 times 25% gives us 33.5. So we're going to round to 34 employees from this group. Then we need to do 57 times 25, which is 14.25. So we're going to round down to 14 employees. 114 times 25% is going to give us 28.5. So we'll round up to 29. And then 76 times 25% gives us 19 employees. So we need to take 34, 14, 29, and 19. 34, 14, 29, 19. This is a longer way of breaking it down that I wanted to show you guys. We break down into, this is 35%, 15%, 30%, and 20% of the company. So this is 100% of the company. We then just times 35%, which is how much of the company is in this portion of the population, times 95, because we need 95 employees, we get 33 employees. So we end up with the same answer, 33, 14, 29, and 19 equals the 95 employees. It's just a longer way of working it out. Okay, we're going to create a dot plot that represents the following data. Time taken to complete homework. So there's 15 minutes, 30 minutes, 45 minutes, and 60 minutes. So 5 students take 15 minutes. 7 students take 30 minutes. 9 students take 45 minutes. And 12 students take 60 minutes. So then we have a number of dots. It should be evenly spaced in terms of this one should be the lowest, then they should go up like that, but it's hard to do it on a computer, obviously. What is the average time taken to complete homework? So we'd need to find the average by adding them all together and then dividing by the number of time or the number of people involved. So 5 people take 15 minutes. So we've got 5 times 15. 5 times 15 would be 75. Then we've got 30 times 7. 30 times 7. Hang on, let me just think about what I'm doing here before I send you down a stupid path. Mm-hmm. 30 times 7. We've got 210 minutes. Let me save you this. 45. That's Luna if you can hear her. Times 9. 405. 60 times 12. 720. So we have an array of different amounts of minutes. What we're going to do is, how many students do we have? 5 plus 7 plus 9 plus 12. We have 33 students. We're going to divide our number of minutes by our number of students, which gives me 42 minutes. So we could say our average amount of time taken is 42 minutes, which would put us closest to our average 9 students who take 45. We've also already worked out that there are 33 students in the class. We can also see that there, 42.72 minutes. And that's a much, much nicer dot plot that I've drawn for you there. All right, observe the frequency distribution table below, filling in the cumulative frequency polygon. Okay, so let's fill out this column first, and then I'm going to show you what this looks like. All right, so, oh, actually, I'm not going to show you the cumulative frequency graph. That's another question. I just got myself confused. Score, 12 frequency for 1 to 9, so we're just going to write 12. Now there's 25 for this column, so we're going to add 25 and 12 together. 25 and 12 gives us 37. We're now going to add 32 to put us to the next column, which is 69. We're now going to add 18 to put us up to the next column, which is 87. And then a further 27 to give us 114. And we can see our answer there is correct. All right, answer the following questions by referring to the stem and leaf plot. Write out all the data points in order. Now, this is a little bit tricky to do with a mouse, so I'm going to put it on the next slide when we have the answer. So let's have a look. What is the average score? To do this, we need to add all of the scores together and then divide by the number of scores. So 10 plus 13 plus 16 plus 21 plus 26 plus 27 plus 28. Missed a 2 there. Plus 35 plus 35 plus 36. Takes me a second. Hang on, guys. Plus 41 plus 41 plus 45 plus 46 plus 49 plus 50 plus 53 plus 56 plus 58. Now, how many data points we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we got 686 when we added those all together. We're going to divide that by 19. We get 36.1, which is our average score. The range of scores is the highest score minus the lowest score. So 58 minus 10, we have a range of 48. And we can see this was our data points written out in order, 36.1 and a range of 48. The marks across 3 subjects of 5 students are recorded in the table below. Represent this data in a column graph. So we have Fran, Jake, Cecilia, Nancy, and Josh, and they have English, maths, and history marks. This is what it would look like if we represented it in a column graph, sorry. So see how there's breaks between each student, but we don't need breaks between the columns when they're all for one piece of data, which is the student itself. So we've drawn out our marks, which go up by 10, 20, 30, 40, 50. We've spaced out our students, and we've included a key. So English, maths, and history, and these are their 3 marks. All right, how do we do really well in classifying and representing data? Number 1, double check your axis. Make sure that the correct variable is in each place and you're not using the independent variable on the wrong axis, or you're using the class on the horizontal if it's meant to be on the vertical. Always double check if you need to include a frequency polygon or line, and don't estimate, so do it properly, please. It will save you so many marks. Always double check the data you're given. It is often mixed up like a stem and leaf plot, and it can be misread if you don't put it in order. Okay, what do you include on your summary sheet? Sampling methods, classifying data, and tabular and graphical representations of data. I would say the third point is the one that I see most often tested in Year 12. They're not really going to ask you questions about, is this categorical ordinal or categorical nominal, or how do you classify it, or how do you sample? So how do you, what is a stratified sample? They're very unlikely. It's very unlikely they'll ask you that in Year 12, very much in Year 11, but not in Year 12. But tabular and graphical representation, so all of that cumulative frequency, relative frequency stuff is very much important to Year 12.